Hello everyone, welcome back to the channel. In the previous session, we have completed about adsorption theory of heterogeneous catalysis. Okay, there we considered mechanism how actually that heterogeneous catalysis takes place. So according to that theory, adsorption theory, how many steps involved? Yes, just recall the concept. According to adsorption theory, heterogeneous catalysis involves 5 steps. Well, what is the first step we said about? It is about whenever the reaction is catalyzed, means we are considering catalytic reactions. First, what happens? All reactant molecules they diffuse. Okay, they diffuse on the surface of a catalyst. So, first step we said diffusion of reactant molecules on the surface of a catalyst is the first step. Then further, next what we said, once reactant molecules diffused, those reactant molecules are adsorbed. Adsorption ಅಂದ್ರೆ second step ಏನು ಹೇಳಿದೆ ನಾನು adsorption of reactant molecules on the surface of a catalyst. First they diffuse on the surface, thereafter all reactant molecules will be get adsorbed on the surface of a catalyst. Next, third step is once adsorbed, what happens? Reactant molecules come close enough to one another so that they interact among themselves and it leads to formation of product. So third step ಏನು ಹೇಳಿದ್ವಿ ನಾವು ಫಾರ್ಮೇಷನ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ ಅಂತ ಹೇಳ್ತೀವ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ ಥ್ರೂ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಹೌದಾ ಥರ್ಡ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ ದೆನ್ ಒನ್ಸ್ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ಡ್ ಇಟ್ ಓಂಟ್ ರಿಮೇನ್ ಆನ್ ದ ಕೆಟಲಿಸ್ಟ್ ಸೈಸ್ ಸೊ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ದ ಪ್ರಾಡಕ್ಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ವಿಲ್ ಬಿ ರಿಮೂವ್ಡ್ ಫ್ರಮ್ ದ ಸರ್ಫೇಸ್ ಆಫ್ ಎ ಕೆಟಲಿಸ್ಟ್ ಆ ಪ್ರೊಸೆಸ್ಗೆ ಏನು ಕರಿತೀವಿ ನಾವು ಡಿಸಾರ್ಪ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. So once product formed, they won't remain on the surface of a catalyst. Rather, those product molecules will be desorbed. They are moving away, or I can say they are removed from the surface of a catalyst. That phenomenon is named as a desorption. So fourth step, desorption of product from the surface of a catalyst. Once desorbed, what is the last step? Diffusion again. Diffusion of product molecules away from the diffusion of product molecules away from the surface of a catalyst takes place. So according to adsorption theory of catalysis, okay, what we said according to adsorption theory of catalysis, okay, so the mechanism involves 5 steps or it takes place in 5 steps: diffusion of reactant molecules, adsorption of reactant molecules, formation of product through intermediate, fourth desorption of product molecules, and fifth one diffusion of product molecules away from the surface of a catalyst. So we consider. Well, now in this session I am going to consider one more type of catalysis, okay, that is called shape selective catalysis. In is now shape selective catalysis by zeolites. Okay, well, what is this shape selective catalysis? First we understand the meaning of this shape selective catalysis. Yes, what it is? Yes, is a type of catalytic reaction. Andre into shape selective catalysis is nothing but it is a type of catalytic reaction. First thing to be remembered here, a shape selective catalysis means what we have to consider, it is a type of catalytic reaction. Okay, it is a type of catalytic reaction. Yes, this catalytic reaction depends on which factor? It depends on the pore structure of a catalyst and size of the reactant molecules. Please remember. So shape selective ಯಾಕೆ shape ಅಂತ ಯೂಸ್ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ since this catalytic, okay, this catalytic reaction, it depends on the what factor? It depends on the size and shape. Okay, these are the major factors. The catalytic reaction which depends on the size and shape of catalyst and reactant molecules. So that's what we are specifying. It's named as a shape selective catalysis. So yes, how we are defining it? It is a type of catalytic reaction. Okay, what is to be remembered here? Yes, shape selective catalysis andre first ಏನು ಹೇಳ್ತೀವಿ ನಾವು? Yes, it is a type of catalytic reaction. ಹೌದಾ, ಫಸ್ಟ್ ನಮ್ಮಲ್ಲಿ ಏನು ನೆನಪಿಟ್ಕೋಬೇಕು? It is a type of catalytic reaction. Well, it depends on what? It depends on the pore structure. It depends on the pore structure ಅಂದ್ರೆ ಏನು ಹೇಳ್ತೀವಿ ನಾವು shape of a catalyst. Pore structure of catalyst. Okay, pore structure of catalyst. And further, it also depends on the shape and size. ನಾವೇನು ಹೇಳ್ತೀವಿ ಇಲ್ಲಿ ಜನರಲ್ ಆಗಿ it also depends on the shape and size of reactants. Not products, actually it is a reactant. So if I consider shape selective catalysis, if they ask for say 1 mark, okay, what is the meaning of, what do you mean by shape selective catalysis? It means first, what is it to be remembered here? It is a type of catalytic reaction. First ಏನು ಹೇಳ್ತೀವಿ ನಾವು, it is a type of catalytic reaction. It depends on what parameters? It depends on the pore structure of a catalyst. It depends on the pore structure of a catalyst and further shape and size of reactant molecules. Hence it is named as a shape selective catalysis. Just I will go through the definition. What it says, it's a catalytic reaction. It depends on pore structure of a catalyst and size of reactant molecules. Okay, size of reactant molecules, and is called shape selective catalysis. Okay, well, now here what is the title I specified here? Shape selective catalysis by zeolites. Zeolites ಅಂತ ಹೇಳ್ತಿದ್ದೀನಿ ಇಲ್ಲಿ, ಹೌದಾ? Yes, what are the zeolites? Say zeolites are chemical substances. First we consider, say zeolites are nothing but these are type of substances. Okay, kind of chemical substances. Yes, these zeolites act as a catalyst. ಏನಾಗ್ತವೆ, the zeolites are well known catalyst. They act as a catalyst. Well, their catalytic activity, or I can say this catalytic nature, the catalytic nature, or I can say the catalytic activity of these zeolites, it's because of what is the reason for it? It is because of their honeycomb like structure. ಏನು ಹೇಳ್ತಿದ್ದೀವಿ ನಾವಿಲ್ಲಿ? It is because of their honeycomb like structure. Means zeolites are a kind of chemical substances. They act as a catalyst. Analytically, zeolites are a kind of chemical substances. They act as a catalyst. They act as a catalyst in various chemical reactions. Their catalytic activity is because of, ಯಾಕೆ ಅವು catalytic activity ತೋರಿಸ್ತಿದಾವೆ ಅಂದ್ರೆ, it is because of their honeycomb like structure. ಅದರ ಯಾವ ರೀತಿ ಇರುತ್ತೆ? They have a honeycomb like structure. Yes, we know what is this honeycomb like structure? A regular hexagons, right? If I consider honeycomb, how it looks like? It has a regular hexagonal structures. ಹೌದಾ? ಈ ರೀತಿ cavities ಇರ್ತವೆ honeycombs. So zeolites, when you look at molecular level, yes, zeolites also have a honeycomb like structure. So because of their honeycomb like structure, they have catalytic activity. Yes, zeolites are nothing but, again I can say here, a kind of chemical substances. What are those? Chemically what they are? Just I will mention it later. Now remember, zeolites are nothing but, yes, a kind of chemical substances. They act as a catalyst. They act as a catalyst because of their honeycomb like structure. Our catalytic activity ಇದೆ. ಯಾಕೆ? It is because of their honeycomb like structure, irregular hexagonal structures. Okay, therefore I said here catalytic activity of zeolites, it mainly because of their honeycomb like structure, that is shape and size of the catalyst. Therefore we say these are well known example for shape selective catalysis. Well, so what I said here, zeolites, basically what is to be remembered whenever you heard about zeolite means, first remember, yes, they are kind of chemical substances. Okay, next ಏನು ಹೇಳ್ತೀವಿ? They also act as a catalyst. They show catalytic activity. Their catalytic activity is because of their honeycomb like a structure. Well, to the concept called zeolites. What is zeolites andre? Basically what they are? Zeolites are, they are aluminosilicates. Zeolites are, they are aluminosilicates with a three-dimensional network of silicates. ಹೌದಾ? Three-dimensional network of silicates ಅಂತ ಹೇಳ್ತೀವಿ. So, in which silicon atoms are replaced by aluminum atoms and which gives aluminum oxygen silicon framework. Just ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಟ್ರೈ ಮಾಡಿ. ಸೊ ಜಿಯೋಲೈಟ್ಸ್ ಆರ್ ಅಲ್ಯೂಮಿನೋಸಿಲಿಕೇಟ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ವೆಲ್ ಫಸ್ಟ್ ವಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವರ್ಡ್ ಬೈ ವರ್ಡ್. ಏನು ಹೇಳಿದೆ ಇಲ್ಲಿ ನಾನು, ಜಿಯೋಲೈಟ್ಸ್ ಆರ್ ನಥಿಂಗ್ ಬಟ್ ದೇ ಆರ್ ಅಲ್ಯೂಮಿನೋಸಿಲಿಕೇಟ್ಸ್ ಅಂತ ಇದೆ. ಏನಿದು ಅಲ್ಯೂಮಿನೋಸಿಲಿಕೇಟ್ಸ್? ಎಸ್, ಇಟ್ ಹ್ಯಾಸ್ ಬೋತ್ aluminosilicates ಅಂದ್ರೆ it has there will be both alumina and silica. Alumina ಏನದು Al2O3, alumina na, so Al2O3 plus silica SiO2 means here I can say zeolite is a combination of alumina and silica. So resultant will be zeolite ಅಂತ ಹೇಳ್ತೀವಿ. So overall what we are calling, they are aluminosilicates ಅಂತ ಹೇಳ್ತಿದ್ದೀನಿ. Further, next what happens, what type of structure they have? They have a three-dimensional framework. They have a three-dimensional structure. Three-dimensional structure of silicates, in which what happens here, silicon atoms are replaced by aluminum. Andre in three-dimensional net what happens? Part, not all silicon atoms, part of the silicon atoms are replaced by which atom? Aluminum atom. So that we are going to end up with a aluminum oxygen silicon framework. So first thing, zeolites are aluminosilicates. Okay, aluminosilicates with three-dimensional framework in which part of the silicon atoms are replaced by aluminum atoms, and they have or which gives aluminum oxygen silicon framework. And regarding structure, we already said what type of structure they have. They have a honeycomb like a structure. Okay, they have a honeycomb like a structures. So if I consider zeolites, yes, zeolites are aluminosilicates with a three-dimensional framework in which part of the silicon atoms are replaced by aluminum, which gives a aluminum silicon oxygen framework. ಕೊಡುತ್ತೆ ಇಲ್ಲಿ ನಮಗೆ which gives aluminum oxygen and silicon framework. Okay, well, now if we consider zeolites, where they are used, actually yes, zeolites are used in which industry? They are used in petrochemical industries. Okay, they are used in petrochemical industries. What is used purpose? So here hydrocarbons. Okay, usually in petrochemical industry what we'll do, we are going to process. Okay, we are going to process hydrocarbon alli ನಾವು process ಮಾಡ್ತೀವಿ. Yes, one of the processes involved is cracking. Okay, cracking ಏನು ಹೇಳ್ಕೊಡುತ್ತೆ ಇದು? cracking ಅಂದ್ರೆ converting higher hydrocarbon into lower hydrocarbons. And one important phenomenon is isomerization. Isomerization ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ? One form of hydrocarbon is converted into another form. We have different type of isomers. Okay, one commonly consider ಮಾಡಿದ್ರೆ cis trans isomers ಅಂತ ಇದೆ. To convert one form into another, yes, these zeolites are used. So zeolites basically they are used as a catalyst in petrochemical industries for cracking and even for isomerization of hydrocarbons. Well, what is the most commonly employed, most commonly used zeolite is, it is ZSM5. Please remember the most commonly employed zeolite, most commonly used zeolite is ZSM5. Well, which converts directly alcohols into gasoline. Alcohol ಅನ್ನು ಡೈರೆಕ್ಟ್ ಆಗಿ ಗ್ಯಾಸೋಲಿನ್ ಆಗಿ ಯಾವುದು ಕನ್ವರ್ಟ್ ಮಾಡುತ್ತೆ? ZSM5 ಕನ್ವರ್ಟ್ ಮಾಡುತ್ತೆ. ಏನಿದು? which is one of the zeolite. ಏನು ಹೇಳ್ತೀವಿ ಇದಕ್ಕೆ? what is this ZSM? Z means okay, zeolite. Yes, sieve, SIEVE, zeolite sieve of molecular porosity 5, that expanded form, but it is zeolite sieve of molecular porosity 5. ಈಗ ZSM, Z ಅಂದ್ರೆ ಏನು? zeolite ಅಂತ ಹೇಳ್ತೀವಿ. S means sieve and M refers to molecular porosity 5. Okay, so ZSM5 is most commonly employed zeolite. Okay, please remember it. Well, now coming to the next concept, enzyme catalysis. ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಏನಿದೆ, ಎಂಜೈಮ್ ಕೆಟಲೈಸಿಸ್ ಅಂತ ಇದೆ. ಹೌದಾ? ವೆಲ್ ಹಿಯರ್ ಇಫ್ ಐ ಕನ್ಸಿಡರ್ ಎಂಜೈಮ್, okay, enzyme ಅನ್ನೋ ವರ್ಡ್ ನೀವು ಬಂದಿರುತ್ತೆ ಬಯಾಲಜಿಲಿ ಎಲ್ಲ. okay, we used to come across the enzyme. Catalysis we know, catalysis a process which is influenced by presence of a catalyst is called catalysis. Now the term is enzyme catalysis, enzyme catalysis anta ide. Well here first we try to understand why we are saying enzyme catalysis and what are these enzymes. So first thing, enzymes are basically proteins, okay, proteinaceous substance. Okay, so what are enzymes? Enzymes are proteins. What they will do, they act as a biocatalyst. Okay, enzymes act as a biocatalyst. It means, why we are saying here bio, since these enzymes are proteins, they involved in various biochemical reaction. Okay, enzymes anyway, they are proteins, they involved in various biochemical reactions, which catalyzes means which increases the various biochemical rate of a various biochemical reactions, hence they are named as biocatalyst. Okay, so here enzyme catalysis means, yes, what we are saying here, the catalysis are various biochemical reactions where they takes place. Yes, they takes place in the bodies of maybe animals or even plants, living organisms. Common ಆಗಿ ಹೇಳೋದಾದ್ರೆ ಏನು ಹೇಳ್ತೀವಿ ನಾವು, living organisms. ಓಕೆ, ಈ ಲಿವಿಂಗ್ ಆರ್ಗನಿಸಮ್ಸ್ ಅಲ್ಲಿ ಬಯೋಕೆಮಿಕಲ್ ಪ್ರೊಸೆಸ್ ಅನ್ನ ಯಾವುದೇನು ಕರಿತೀವಿ ನಾವು, ಲೈಫ್ ಪ್ರೊಸೆಸ್ ಅಂತಾನು ಹೇಳ್ತೀವಿ. ಹೌದಾ? ಇಫ್ ಇಟ್ ಮೇಂಟೈನ್ಸ್, so the numerous reactions occur in bodies of animals and plants to maintain life processes are catalyzed by the substances, proteinaceous substances, they are called enzymes. So basically an enzyme anta ಹೇಳಿದ್ರೆ ಏನು ನೆನಪಿಟ್ಕೋತೀರಿ, is these enzymes are proteins. Okay, enzymes are proteins which catalyzes various biochemical reactions, hence these enzymes are also called biocatalyst anta kuda karitivi. Okay, well now here whatever the various reactions which takes place or which occurs in the bodies of animals and plants which maintains the life process are catalyzed by a proteinaceous substance are called enzymes, and that process is called enzyme catalysis. Okay, so the phenomenon, okay, the phenomenon of catalysis which is influenced by presence of enzyme, so called enzyme catalysis. Okay, well thus enzymes are termed as a biocatalyst and this phenomenon is called biochemical catalysis. Now, if I consider example for enzyme catalysis, now here one of the enzyme called invertase, invertase, which converts cane sugar into glucose and fructose. ಏನಿದೆ ನಾನು ಒಂದು ಎಂಜೈಮ್ ಹೆಸರು ಹೇಳ್ತಿದ್ದೀನಿ, ಏನದು invertase. Invertase what is? It is an enzyme. ಹೌದಾ? Invertase is an enzyme which converts cane sugar. Yes, what is cane sugar? It is actually sucrose. Okay, cane sugar ಏನದು? It is sucrose which converts sucrose into glucose and fructose. ಯಾಕೆ ಇದಕ್ಕೆ ನಾವು ಇನ್ವರ್ಟೇಸ್ ಅಂತ ಹೇಳ್ತಿದ್ವಿ ಅಂದ್ರೆ, ಇಟ್ ಕನ್ವರ್ಟ್ಸ್, ಓಕೆ, ಸುಕ್ರೋಸ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಗ್ಲೂಕೋಸ್ ಅಂಡ್ ಫ್ರುಕ್ಟೋಸ್. ಸೊ ಆಪ್ಟಿಕಲಿ ದೇರ್ ಇಸ್ ಎ ಚೇಂಜ್ ಇನ್ ದೇರ್ ಆಪ್ಟಿಕಲ್ ಆಕ್ಟಿವಿಟಿ, ಅದಕ್ಕೆ ನಾವು ಇನ್ವರ್ಟೇಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. Well, now if I consider chemical equation, sucrose, ketol H22O11. So invertase, what happens when aqueous solution of sucrose is treated with invertase enzyme? What happens? Sucrose is get hydrolyzed, is get converted into glucose and fructose. ಏನಾಗುತ್ತೆ, ಆ sucrose ಏನಾಗುತ್ತೆ, get converted into glucose and fructose. So say here sucrose is optically inactive. Okay, sucrose ಏನಿದು which is optically inactive, it don't show any optical activity, but glucose, this combination glucose and fructose, they show optically active. ಇವೆರಡು ಆಕ್ಟಿವ್ ಇರುತ್ತೆ, ಅದಕ್ಕೆ ನಾವೇನು ಹೇಳ್ತೀವಿ, ಇದನ್ನ ಇನ್ವರ್ಟ್ ಆಗುತ್ತೆ, there will be change in their optical activity, or you can say optical property. The inactive is get converted into active, so inverted, reverse. The enzyme used here named as a invertase. So this is one example. Then coming to the second example, so what I can see here, zymase is one more enzyme. Zymase. So Gymase, what it will do? Gymase converts glucose into ethanol, ethyl alcohol, or I can say ethanol, and carbon dioxide. So Gymase in madutte. Gymase is a kind of enzyme which converts glucose C6H12O6. Okay, is converted into ethanol and carbon dioxide. Okay, ethyl alcohol agi convert agutte. So Zymase which converts glucose into ethanol and carbon dioxide. Okay, well, is also one of the enzyme catalysis. Example for enzyme catalysis. Now coming to the next example, say example number 3, what is that? Diastase is a one more enzyme, diastase. So this enzyme catalysis, the process and enzyme involved is very important. So the third example here, enzyme diastase which converts starch into maltose. Starch, what it is? Starch is a polysaccharide. Starch it is a polysaccharide. So when starch is treated with the diastase enzyme, diastase, if you use, what happens? Starch is converted into maltose. We used to call malt sugar. So maltose is an example for disaccharide. Okay, so polysaccharide is converted into disaccharide. Starch is a polysaccharide, maltose is a disaccharide. So starch is converted into maltose with the help of diastase enzyme. So it's also example for enzyme catalysis. Say starch, as I said, it is a polysaccharide, therefore how it is indicated? C6H10O5 taken n times is a polysaccharide. Now, when starch is treated with the diastase enzyme, what happens? The conversion of maltose. Starch is get converted into maltose. Okay. Well, a polysaccharide is converted into disaccharide. So diastase is the enzyme. Now, one more example. Say maltase. Maltase is a enzyme. What it does? The maltase converts maltose into glucose. ನಾನು already ಏನು ಹೇಳಿದೆ ಇಲ್ಲಿ? Maltose is, it is a disaccharide. ಹೌದಾ? So maltose is a disaccharide. Maltose is converted into glucose. Glucose is a monosaccharide. Glucose is monosaccharide, means disaccharide is converted into monosaccharide with the help of what is that enzyme? Maltase. Maltase converts maltose into glucose. So chemical equation, so ketol H22O11 maltose. So on hydrolysis, it undergo hydrolysis in presence of maltase enzyme and get converted into 2 moles of glucose C6H12O6. Okay. Now, if you consider one more example, so enzyme urease, enzyme ಏನಿಲ್ಲಿ urease ಅಂತ ಹೇಳ್ತಿದ್ದೀನಿ. What it do? It converts urea into ammonia and carbon dioxide. So, well, equations, urea NH2CO NH2 on hydrolysis in presence of which enzyme? Urease. Okay, urease enzyme. What happens? Urea is get converted into ammonia and carbon dioxide. Okay, well, next example, enzyme pepsin. Okay, enzyme is pepsin which converts proteins into peptides. So ಈ proteins ಏನಿದು usually we say polypeptides ಅಂತ ಹೇಳ್ತೀವಿ. Polypeptides of amino acids. Okay, polypeptides of amino acids. Amino acids are called proteins. Now what happens when pepsin is used? Pepsin converts a polypeptides, okay, that is proteins into peptides. Peptides means lower, okay, lower molecules. Higher polypeptides are converted into lower polypeptides. In stomach, pepsin which converts proteins into polypeptides, or you can say proteins into simple peptides in stomach. And one more enzyme named trypsin. Pepsin and trypsin, they are involved in, okay, digestion of proteins. So here pepsin what will do, which converts polypeptides into lower amino acids in what, in stomach. So we say which converts proteins into peptides in stomach, and one more enzyme trypsin which converts protein into amino acids, proteins into amino acids where, in the intestine. Then peట్టుకోవాలి two enzymes pepsin and trypsin. Pepsin where, pepsin involved in digestion of proteins in stomach. Okay, stomach ಅಲ್ಲಿ ಏನು ಮಾಡುತ್ತೆ, the higher polypeptides are converted into lower peptides. Polypeptide is converted into a lower peptides in stomach, while trypsin which involve in the digestion of proteins in the intestine. Okay, intestinally all type of protein, all type of protein is get digested in the intestine. That is, all proteins are get converted into amino acids. Polypeptides are get converted into amino acids in the intestine. Okay, well, so lactobacilli is one more. Okay, enzyme lactobacilli is an enzyme lactobacilli which converts milk into curd. Okay, well, as like, if I consider, there are various enzyme catalyzed reactions. Please remember the enzyme and the process involved. Well, with this, I am going to conclude about this session. Again, in the next session, we discuss the continuous part of the chapter. Okay, thank you. Be safe.